Miro Hodak, Global AI Architect for Lenovo DCG, and the subject of my talk is Enterprise AI, enabling the next wave of digital transformation. AI is certainly something that is transforming key industries, and the reason why it's sort of become widespread and so successful is that it effectively brings new capabilities that were not available before. Those are basically along two lines. The first one of them is that it has an ability to find hidden insights inside the mountains of data, which otherwise we would not be able to get. And the second one is that it really brings capabilities to being able to work with images, language, sort of basically the file that up until now, the file format that up until now has been really domain of people, whereas and now it's possible to basically do it in the machine. If you look at particular industries where this kind of a transformation is taking place, there's certainly probably isn't an area where this would not be applicable, but the main ones would be manufacturing, certainly, where anything from quality control to predictive maintenance is very important. Retail, absolutely, where loss prevention and shelf restockings are very hot topics. In finance, we would look at things like credit decisions, risk management, definitely fraud detections. And very importantly, in health, where medical imaging is very important topic, so that, for example, computer and artificial intelligence enabled models enable diagnosis based on medical images, where they would provide sort of assistive role to physicians. Deploying AI brings with it several considerations that needs to be looked into when we are trying to productionalize AI for a particular use case. This is unfortunately this is not a straightforward process, because we kind of need to it needs to be fit and sized to appropriate use case, to a particular deployment considerations, such as if we are doing it directly on the side, as it often is done, done. How can we bring the solution? What is does the hardware support it, and what sort of software solution go on top on it? On a basic level, there are two types of AI. There is AI training, which is really something where that has a characteristic of high performance computing workloads. So that is, in that case, we care about performance, we care about data capacity, what exactly is the performance, how are this is a multi-user kind of type of deployment, so how is it going to all work together? However, it's the AI inference that is actually the way how AI is being deployed, and here the set of considerations is different. What we need to look at is we're looking for something in software and hardware that brings us low latency, that is enough, that is low enough for a particular use case. We need to have something that provides enough throughput for the data that's going to be streaming in, and we also have a physical deployment consideration, especially, as I said, if we're bringing the compute to the data, so that we would sort of do some kind of edge deployment. In that case, we need to know where the hardware is going to be placed, and under what conditions, what are the environmental conditions, etc. Right? But once it is once that those basic things are taken care of, the next set of considerations is what type of architectures we need to support a particular application that we want. Right? We have on a kind of hardware level, we have several choices of particular servers. We have a choices of accelerator, processor, storage, networking, right? So these kind of um, and there's a and oftentimes a particular use case may require sort of a right combination of these factors, right? Uh, we also need to look at what is the appropriate price performance, performance per watt are often important as well. Now, how do we determine the optimal infrastructure for the solution? Again, not a straightforward problem, not a straightforward question, and something that is definitely a workload and that is depends on a particular set of facts on the ground, right? So we need to look into overall architecture, overall architecture that we need to be deployed, not just, for example, just hardware itself or software itself. It need to be considered all together. We again similarly need to sort of measure the performance of the entire system once it's deployed, and again we need business considerations such as cost, energy, location need to be all factored in. When deploying AI, there are several different architecture based on kind of a use case and particular deployments that we need that are shown over here. The first one is deployment of AI training. This is something very computationally very intensive. That's what is usually done in a data center, and we try to sort of spread out the computational load across multiple GPUs, across multiple nodes. So that's hence the kind of a use case here that we have one workload that spans over a computational cluster. And we also need to explicitly account for a storage of data, because usually we work on a data set that is very large, and all of these compute nodes, all of these GPUs have to be able to access the same data set. In terms of inference, I sort of broke it into two distinct use cases. So one of them is a data center inference. Now, what's happening here is that each of kind of inference processes is relatively light process. So each of these AI servers is now capable of handling several of these inference processes. And so what's happening is that we would have multiple streams of input coming here, coming in, and multiple streams of output coming back. We of course have to make sure that the latency is within what we expect. That needs to be something in terms of milliseconds. Users have to get response to their queries. And the last kind of another option for inference is doing the inference on the edge. That is that where we bring compute directly to the data. What we would use for that is a small edge compute servers that would, if they are GPU accelerated, would use like low-end accelerator such as T4, for example, and oftentimes there would be some kind of management and storage system that would connect them together. Well, talking about AI training, especially ones that is GPU accelerated, one of the most important consideration is sort of what is the relationship here between compute and storage. This has been sort of looked at before. But unfortunately, a lot of the existing solutions basically take the approach that they combine most expensive compute and storage, put it together. Now, this certainly gives us something that provides the best possible performance, but it's not very but it's something that is very expensive. It's not something that is sized correctly, right? And whereas sort of the approach we have been taking was was a bit different. That we kind of, or at least the work that I've been involved is, usually we try to sort of size the storage relative appropriately to the compute, right? Oftentimes we actually do not need full set of NVMEs and the highest network speed, even though it may work in some cases, it's not always necessary. This has advantage, of course, being being something that can be cost effective, while not even be compromising on performance. And the other thing is that this way, this really send the message to customers that we do not need that AI doesn't need to AI high performance AI system does not need to does not need to be extremely costly, but can be done uh, at a sort of budget friendly cost. When talking about AI training, setup, an important thing is how to sort of size storage relative to the compute, and there are sort of several aspects here. One of them that is straightforward is capacity. We know that we want something large, right? Data sets nowadays are very large, and therefore we need something with a large capacity. Also, we need some kind of shared parallel storage so that when we use the data, we can have multiple servers sort of read from this type of storage. So this is kind of a problem that is, and so this type is kind of well known. The second is what is kind of the interplay between for storage kind of throughput and latency. One kind of important thing is that latency is oftentimes not critical for AI training, and the reason for that is that usually data is prepackaged in a large file, which is sort of a good way of prepare the data. To make sure that we get maximum performance. And second, GPUs process data in batches. What it means is when we do two of these things, then um, latency doesn't come into play because we always read, always play with, always use large blocks of data. So, and what is important instead is throughput. We need to have again, and in terms of throughput, what we need to do, we need to make sure that there is sufficient throughput so that none of the, so that GPUs or whatever compute elements we're using are not starved, right? And with that comes the question of how much throughput is really needed. Now, this is something that is workload dependent, but we can look at some particular use cases, and the one that is still relevant and often used is the Resonant 50 ImageNet training. And when we look at recent sort of published results on A100, we find that what sort of the best performing results for this type of use case get about 2.5 gigabit per second per A100 GPUs. And other use cases out there sort of stay roughly within this. So this is kind of a kind of reasonable estimate that may represent a lot of use cases. Two types of possible AI deployments are shown over here. These are the AI training architectures I worked on, and the difference between them is that the left one is a kind of simple setup where everything running over fairly slow networking, whereas the right-hand side shows something that is more advanced, that we have a faster speed for GPU to GPU communication, but we actually have kind of the same lower-end storage connected to the same over the same slower speed network. So here I'm showing how these two particular setup compare in performance. So on the left-hand side is shown results from the simple single network that is fairly slow. And here what we find is that the scale out is actually working pretty well for 2 nodes, but going beyond that is we lose performance. If we do the more advanced setup, we can get much better scale out. So while one would think that we should go with the setup on the right. However, the message here is actually that single fairly slow network is actually oftentimes something that may be practical, because in practice a lot of trainings are even single node. So oftentimes, if you're looking for something that provides good single node performance with occasional scale out, we can look to the architectures that we can look to the architecture with where networking is not necessarily the highest available. This all has been published in a Lenovo reference architecture that can be found here, and also this has been a joint work between a Lenovo NetApp that has been published as a technical report, and this this work has got an AI Breakthrough Award for best machine learning platform. The next topic is AI inference at the edge. And what I'm showing here is a reference architecture I've just been recently working on. This has several components. So it consists of several edge servers that can potentially be connected to various sensors and handle their input, and also for a kind of single network storage, right? So what network storage does is that really it would hold all the models, right? It stores all the input data because the edge server have limited storage, and will also serve as a central point for sort of managing server, central point for bringing in new version of AI model, etc. Right? And so we have set this up using Sync system SE350 edge server, each one which was equipped with T4. We have used a Lenovo DM5000F storage or NetApp C190, and what we've done as a part of performance testing was basically testing performance where all the data held locally, as well as where where we have multiple servers connected to the same storage. And what we have found that with this type of networking setup, in particular the networking speed shown over here, that the performance we're getting out of this setup is almost exactly the same as the one for individual servers, which really means that networking does not bring any overhead. This is something that will be particularly applicable to retail, manufacturing, etc. And this has recently been published as another joint work between Lenovo and NetApp as technical report. And this is something that also will be coming out soon as a Lenovo reference architecture. The last topic is evaluation of AI performance. And there's a very useful kind of benchmark or cross-industry collaboration that sort of strives to provide fair and balanced measurement of AI performance across different use cases, called MLperf. And there's been several lines published, and the slides show several kind of interesting insights we can get. In particular, we can sort of see that GPU provides has a significant both performance and performance per watt edge in terms of performance. Lenovo has participated in latest inference rounds, and our intentionally sort of continue being active going forward, so that the performance of our hardwares can be sort of easily evaluated against competition. And the last round that has been published so far, version 0.7, has sort of showed our expertise in a very positive light. The new results will be released very shortly. While I cannot talk about particular results, Lenovo is one of the only two vendors that has been submitting, that's been working with A4. So the new data will of course show how this particular GPU compares uh, against other GPUs in the AI tasks. Finally, I would like to summarize. Deploying AI is something that requires multiple kind of layers of considerations. We need to not only know what is our particular situation, but we need to know or what are our AI models. We also need to take into account uh, uh, what what kind of hardware setup do we need, how are individual parts sized, what we'll do in how do we handle model and data management, those kind of things. I touched on some of these topics, but this is certainly uh, the underlying issues um, are fairly complex and certainly require more consideration. In particular, we looked at several types of GPU accelerated AI architectures. This would be for data center AI training, data center AI inference, and AI and edge AI inference. Uh, with that, we come to the end of my talk, and I would like to thank you for your attention.